My thesis is on describing and manipulating how salts flow through channels as small as 1/1,000,000th the width of a hair. Let me take you down to this scale where I work, the nanoscale. Things become different. Physics can change. For example, if I take a small enough piece of silver, a nanoparticle, its color becomes blue. But let me get back to salts. We call them ions. Ions are so important because they regulate the activity inside of cells, which are the building blocks of all living things. The surfaces of all our cells are decorated with ion channels, which are constantly moving salts in and out with awesome efficiency. That makes ion channels a source of inspiration for engineers like myself, who try to invent new technologies by copying what we see in nature. I do this by studying how salts move through tiny straws. We call them nanopipettes. In my work, I didn't notice nanoscale effects on salt movement, like silver turning blue, until I filled my pipettes with tiny bubbles and tiny tornadoes. This is a microscope image of nanobubbles inside a nanopipette. On the left is a fluid flow simulation of nanovortices inside a nanopipette. I engineered these bubbles and these vortices to make my pipettes look like nature's ion channels. So these breakthroughs could help us improve dialysis machines or create more elaborate and compact artificial organs. In a whole nother set of experiments, I scan nanopipettes over the surfaces of real cells. In this work, I use the same bubbles and vortices to augment the capabilities that I have during this work. This innovation allows me to understand how cells are able to perform as the building blocks of nature. Using these techniques, I've discovered properties of bacterial cells which cause the common cold. These insights can help us engineer new surfaces which would prevent bacteria films from growing. And if we did this, we could stop illness from spreading in hospitals or public places. I'm finishing my PhD by doing the same thing with brain cells. The billion-plus cells in our brain communicate with each other at nanoscale connections called synapses. By studying them, I'll help us understand how our brains are able to form memories, solve problems, and even give 3-minute theses. Thank you.